Very good evening, all of you. So welcome to another live session. Hello, everyone, all the people on the YouTube. I hope you're doing good as well. And I hope you're all enjoying as well, learning so many different concepts of the 11th grade. All of you have recently moved to the journey of 11th, and it's very different from your 10th, right? In first lecture, we discussed a bit about that as well. Now your method of learning has to be changed. Now the level of learning has completely changed. The amount of syllabus has completely gone up. So many things you have to do very differently from the last year and whatever you have done till the last year. Okay. And in that series, we are learning some topics which we will be continuing or learning in more detail in the regular batch, which will be starting from 10th May, as all of you know. So all the people on YouTube who are watching the lectures. So if you want to continue the classes, if you want to learn in the same way, in more detailed way, then you all can contact askIITians. You have the link in the chat box. Please contact from there. All right, guys. So in the series of multiple topics that we are discussing, today is another interesting topic, which is about relative velocity, isn't it? So today we will be talking about relative velocity, this new concept. So let me share my screen and begin. Relative velocity. The concept today is so interesting. It is so significant in physics because you've heard about the most famous scientist in physics. Who is that? Who is considered to be the most intelligent one out of all? After Newton, somebody who even rectified the laws of Newton. Yes, Einstein. Einstein actually rectified the old theory of gravity by Newton with his new theory of general theory of relativity, right? And that general theory of relativity, the idea for it came from the relative acceleration only, relative velocity only. So you all have heard about the story, right? That how Einstein got the idea. You all have heard about the story of Newton getting the idea because the apple fell on him, on his head. And that's how he got to know that, yeah, there is a gravity that exists, a force that exists. But you know what? There is a similar story for Einstein, how he got the idea for relativity. And so his story was that he was one day sitting in his office, and out there from the window, he saw a man who was cleaning the window. Right? You know, in West, usually in US and all, and Europe, the buildings are usually having glass windows, and they are constantly being cleaned by the staff. So they actually clean it from the outside, and they are almost at the danger of falling anytime. So they have to wear every safety guard and all those things. So Einstein actually was watching one of the window cleaner, and he got a very weird idea. Nobody could have imagined that idea, what he imagined. And you know what he thought? He thought, what if this window cleaner falls from his position? What if he suddenly falls? And guess what? Einstein says the most brilliant idea I had, or the most brilliant experience I had in my life, was imagining a window cleaner falling off the window. That's what Einstein said. But you may seem he seems to be a sadist. He wants to see the death of the person. No, he thought everything before he hits the ground. He did not imagine that person hitting the ground and dying. He thought of in between, the motion that will happen in between, right after it falls to before it reached the ground. In between that part, what that person would be feeling, what would he be visualizing at that point of time, is what Einstein thought. And that what we call as the relative frame of reference. He actually thought how world looks like in his own frame of reference. Now, I'll not go in the detail of what all he did and how Einstein actually shaped it into the relativity theory, but you can easily understand when you are looking at the window cleaner, you will see him falling down, right? But imagine you are that person, that window cleaner who is falling. And now you see a person in the building who is on the 7th floor from where you fell. So you're cleaning on the 7th floor. There was a person sitting in front. Mr. Einstein, let's say, was sitting, and suddenly you fell off. How will you see Einstein now? Can anybody tell? A person who is falling, how he will see? Yes. So Ben is correct. Cavalier is correct. You will see that person going up. Think about it, guys. If here's the building, these are the top floors. On 7th floor, Einstein is sitting, and let's say this person is falling. He is going downward. So according to him, he is moving away and away from Einstein. The distance is increasing. And whenever you observe from your frame, that means now you are that person. The world of relative velocity is so crazy. It says that I never move. So whenever you observe from your frame of reference, you would always say that I am not moving at all. It's the world which is moving up. The buildings around me are going up. That's the way of imagining. So very crazy idea. That's why in 1915, when Einstein gave his theory, he was ridiculed. He was like, you have written something really crazy. But 4 years later, in 1919, an experiment was done in Britain, which actually proved that what Einstein is saying is absolutely correct. It's no longer a crazy idea. So for 4 years, Einstein was ridiculed for his theory of relativity. Only after that, the experiment was done, he was actually given the tag of celebrity. Every newspaper started printing about it, because what he was saying is that Newton was wrong. That's what Einstein was actually saying. And it needs guts to say that Newton was wrong. Newton had the same reputation like what Einstein has today. Imagine a scientist come up and say Einstein is wrong. What will you do? You will say, are you out of your mind? You are calling Einstein wrong? He is such an amazing scientist, physicist. You can't do that. Same thing people told to Einstein. You can't say Newton is wrong, but he actually proved how Newton is wrong. Okay, so I can't go in detail that what all he did to prove him wrong and what theory he himself gave it. That is, by the way, called as the relativity. Two relativity theories are there. Special theory of relativity first he gave, then it was generalized, so it is called general theory of relativity, which talks about gravitational fields and all. Okay, so that's how it goes. Now we will be discussing about that particular thing which Einstein thought, seeing the world from others' perspective. That's what relative velocity is all about. So let's see a few more of those things, crazy ideas. Now let's be crazy like Einstein himself. Suppose you are walking towards a wall. No sane person would do it, but that's what I'm saying. You would have to be crazy for today's lecture. Suppose you start walking towards a wall. Now, ideally, any sane person would say that, yes, I'm walking towards wall. Wall is at its own place. I'm just moving towards it. But now enter the realm, the craziness of relative world. The relative world says the person who observes is never moving. The observer is always at rest. It never moves. So now, like a crazy idea, you will say, I am not moving. It's actually the wall that's coming towards me. Okay, that's the world of relative velocity. Is it clear? If two objects are moving towards each other, let's say A is going towards B and B is coming towards A. Ideally, A should say that, okay, both I and B are moving towards each other. But the craziness of the relative world would say, no, A is at rest if A is observing. And B is coming towards A. But obviously now he will come with more speed. Both the speeds will be now taken up by B only. Do you guys realize that? Because when you walk towards the wall, if let's say you're moving at 2 meters per second, what do you say? You say, I'm not moving. The moment you observe from your end, you say, I'm not moving. My speed is 0. Who told you I'm moving? So then who is moving? You say that the wall is coming towards me with 2 meters per second, right? So whenever you observe in a relative frame, your velocity is taken up by the other person you're observing. Observer gives up his own velocity to the person or the object which is being observed. Is this point clear? So similar thing I can tell you here. If let's say A was moving with 20 meter per second, B was moving with 30 meters per second. So according to A, he is not moving. B is coming towards him with how much speed? Well, 30 of his own. And A gives up his own velocity to B and he gives it as 20. So now what A will see? A will see that B is coming towards me with 50 meters per second, much faster than he actually is moving, right? So that's the world of relative velocity. And you might think that what do we achieve by doing this? Isn't it just a game? Isn't it just for entertainment purpose? What else it does for us? Imagining things like these. No, it helps you a lot. It helped Einstein to generate a new theory. Imagine. So how much help it can do to you? You can only imagine that. All right. So let's see how we will going to do these things in detail. First of all, I gave you an idea of what relative velocity is all about and this crazy world of relativity is all about. Okay. Now we'll just dwell in more detail. All right. So first, I will again begin an example. I gave you the example of things moving towards each other. I would also like to give an example of things moving in the same direction. And then we will see how the crazy world would going to work over there. So imagine that here's the road and a person is standing on the footpath. He is at rest. Person A. He is not moving, he's just standing on the footpath. And now suppose here, a high-speed car is moving. The car, let's say, is denoted by B. So a high-speed car is passing from the road. Its speed is 80 kilometers per hour. So fast this car is moving. So imagine that if you are a person A who is standing on the footpath, how will you find this car moving? So fast, right? It'll just disappear in a flash. Immediately just it'll disappear. That will be the scenario from your end. That's how you will see it. Now, suppose that A also gets a bike out of nowhere. If you all have played GTA, a game, then you know there are cheat codes where you can get a bike out of anywhere, a car out of anywhere. It just falls. So imagine that person A uses a cheat in real life and suddenly a car falls and he also starts moving now with 60 kilometers per hour. And also believe that the person is not Salman Khan because he's moving on footpath now. So if he's the person who also starts to move, now what will be the scenario? How A will going to see B now? Will he appear equally fast now? No. Now he will appear moving very slowly. Dhanush, if you will call it 140, then don't you think it is much faster then? 140 means even faster than 80. Well, that's not true, isn't it? Now what the person will see? Now the person will see that the other car is going very slow compared to him. So we represent it like this. Now what will I be representing? I will be writing it as VBA. Now look at this subscript. How this subscript is read. The subscript is read as this: velocity of B with respect to A. The observer is always at the end. So who is observing here? A is observing. So you will keep the A at last because he is the observer. So VBA represents velocity of B as appearing with respect to A, which is nothing. All of us have given the answer. It is nothing but VB minus VA. It's 80 minus 60. I think every individual of this class has answered it. isn't it? Now that is exactly how the formula of relative velocity is derived. What is the formula of relative velocity? Whenever you have to find speed of B with respect to A, just subtract their speeds. That's all. All right. Now you would be thinking that it's fine here, but we didn't subtract in the first example you gave. In the first example, when it was 20 and 30, we should have subtracted and should have got 10, but we got the answer as 50. Something looks fishy here. No, actually it's subtraction there also. Yes, it's subtraction there as well. But the only difference is if 20 was moving in the positive direction, then how B was moving? B was actually moving in a negative direction. So that was actually negative 30. So there also you subtracted. You did negative 30 velocity of B minus velocity of A, which is 20. And that's how you got negative 50. And do you see the final velocity was also negative? What it suggested? That he will appear to move towards left with 50, which is true, isn't it? So guys, first of all, try to understand things in practical way. I don't want to jump into the formula. I could have started this topic by giving the formula first. I could have begun by saying, okay, relative velocity is this, represented by this, and this is the formula, but that's so boring. I have a way of teaching where formula should not be introduced until unless we don't visualize it. Only after visualization is done, now formula just remains as a formality. Okay, so now let's put up the formula. So quite clearly we have got the formula. Whenever we have to find velocity of B with respect to A, since we are talking about direction here, left, right, it's better to put a vector sign. VB a vector is nothing but VB vector minus VA vector. Achha, by the way, we saw that A observed B going with 20 km per hour. B was moving faster. What if I ask you how B will observe A? Velocity of A with respect to B. What do you think? Now you sit in the car B and try to observe A. Yes. Negative 20. Yes, numerically, mathematically, it's telling that it's negative 20. But what does it mean practically? Yes, exactly. Negative implies not slower. A will appear to be going backward. Again, the world, crazy world of relativity. Think about it. A is actually moving forward, but according to B, he is going backwards. But don't you think that's what you see whenever you overtake a vehicle? What have you seen then? Whenever you overtake a car, the car you're overtaking, you can easily observe it going backward because you have just overtook it. Can everybody see this in real life? Overtaking a car makes that car appear going backwards. So that's again the crazy world of relativity. So here I write that if I was supposed to find velocity of A with respect to B, if I reverse the observers, then this formula also reverses. Instead of VB minus VA, now it's VA minus VB. And that's the relative velocity formulas. But formulas have come only after you first had the feel of the concept. All right, all of you can note down, then we'll see how to solve problems on this, how it will going to help us. Okay, everybody done writing? So see, there is a very short way of remembering these formulas in case you get confused. See, when it is BA, you just keep the order, you just split them, B and A. When it is AB, then also you maintain the order, you just separate the variables. It's A and B, right? So whatever it is, whether it is BA, AB, or some CB, CA, whatever it is, just split them and put a negative sign in between. That's how it becomes a formula. So now signs are very important. Okay, be very careful about the signs. So let's see how we're going to deal with this. I'll give you some example and all of you try to solve. Please answer in the private chat so that answer remains private. Nobody else is able to see it. I will give you 3 objects which are moving randomly. Object A is moving to the right with 20 meters per second. Object B, on the other hand, is moving to the left with 40 meters per second. And object C is moving to the right with 60 meters per second. So you have to give me 3 speeds, 3 relative speed or velocity, I should say. Velocity of B with respect to A, velocity of A with respect to C, and velocity of C with respect to B. These 3 relative velocity you have to give me. And just that we all have a uniform answer, I will give you that right direction is positive and left direction is negative. So all of you can try this. Yeah, so please also give which part you're talking about. That is also important. No, Ellen, your answer is wrong. Only the first part is correct. No, Mohammed, that's also wrong. Sheikh, what is the answer? Ben, you got the first one correct. Kishore also got the first one correct. No. So far, none of you is getting all of them correct. At least one of it is going wrong for everyone. So please recheck, calm down, be very careful while writing the formulas and subtracting. No, not correct. Okay, some of you have got the correct answers now. Yes, some of you have got correct now. So it's time that we discuss and see what is going on. So when it is VBA, I told you the trick. Just separate the variables and put a negative sign. What is velocity of B? Well, that's to the left. It's negative 40. What is velocity of A? That's to the right. So it's positive 20, but we have to subtract. That's negative 60. That's the first answer. All right. So according to A, B goes at 60 meters per second in the left direction. And don't you think you could have directly done it also? A is moving to the right, B is coming towards him. So he will see B coming much faster towards him with 60. And towards him means left side. So negative. So every time you don't even have to use formula. You can also do it by visualization. What will be going on? Okay. Now VAC. So what is VAC? Again, split the formula. VA minus VC. Velocity of A is again positive 20 minus velocity of C is also positive. So we get a negative 40 meters per second. Again, we can visualize it. C is moving really fast and A is moving really slow. So according to C, A is going backwards. C is overtaking A, right? So A will appear to go backwards. That's why negative, isn't it? And now let's see the last one, VCB. Again, the same formula. Just separate the variable, VC minus VB. VC is positive 60 minus VB. B is negative 40. And that's 100, positive 100. Because you are observing with respect to B. According to B, C is coming towards him much faster than 60. It's coming with 100 towards him. And towards him means in the right direction. That's 100, positive. So I guess now all of you would be able to do the questions of relative velocity. Okay, so once everybody is done writing, once they've understood, please tell me. Sir, could you explain again? Yes, Muhammad Abdul, which part? Which one? So I mean, which one? Like the VBA, VAC, VCB, which one you didn't understand? Because all of them use the same thing. So what is that same thing which I told? Whatever you have to find, whether BA, AB, you just separate them and put a negative sign. So when we were finding VAC, what did I do? I just separated A and C, put a negative in between. And now all you have to do is just put the values of V and VC. VA is 20, VC is 60. So you just subtracted them, and that's how we got the answer as negative 40. Now substitution has to be done along with the sign. See, because left is negative. So in the third part, when I substituted B, you can check I did it using a negative sign. Because B is moving to the left, its velocity is negative. Rest, the formulas are same. Just subtract in the order. Okay, got it? Nice. All right, guys, anybody else having any doubt? Please give a thumbs up if you all have understood. We can move ahead then. Should we move ahead? I can see on YouTube somebody has asked a doubt. Sharad has asked a doubt. Sir, AC should be 80, right? AC you're talking about. VA minus VC. No, it won't be. A reason you try to understand, Sharad, because A is also moving in right direction and C is also moving in the right direction. So speeds can't add up. They have to be subtracted only, right? It's the same example when you were standing on the footpath and high speed car went. First it appeared very fast, but when you also started moving, you started chasing the car. Then it appeared to move a little slower. So that's why it will be this way only. Okay, Jay. No issues. All right. Let's move ahead, guys. Now, so far we have learned relative velocity. Question appears, what is, first of all, the use of it? Is there any use that we can have out of this or not? So actually we have a great use of relative velocity. And let us take some question and see how we can use it. First of all, try to do this question as you will normally do it. Don't try to put any relative velocity concept for the timing. Just do it normally with your knowledge so far. Suppose there is a car on this side. Yeah, so that's a nice little car which is moving in this direction. And there is a truck on the other side. Both are traveling towards each other on the same road. Now, nothing to think negative over here. Think of it as it's just the testing for the strength of the car. It is just having dummies inside. No actual human being are there inside. So crash testing is going on in some automobile industry factory. Okay. So the car is rushed towards a truck. Both are running towards each other. Right now, they have been kept 60 meters apart. 60 meters distance is there. The car is moving with 2 meters per second, while truck is moving with 4 meters per second. Now, let's say the moment they are here right now, 60 meter apart, the moment they start, now we will be counting the time. So both when they started, our stopwatch was showing 0. Okay, we had a stopwatch. The moment they started to move, we started the clock. Now they are continuously moving towards each other. What will happen? After a time, they're going to crash. So after time t, let's say they crash. I guess you can easily understand truck would have traveled more distance in collision compared to car because it's moving faster, isn't it? So crash very possible would have taken somewhere here because truck has traveled a lot compared to car. So first thing you have to tell is after how much time the crash took place and how much distance away from the car it took place. Question is clear? Here the crash has taken place. Okay, yes. So Nrityashri got correct. Both answer you give, Kishore, time and distance both. So far, 2 correct answers. Yes, Yafi is correct as well. Yes, Samiksha, time is correct, but what about distance? Everyone give both together because if you find one, the other is so easy. Just one step to find the other. So Mohammed Abdul, question is very clear. I mean, most of it has been drawn. Car and truck moving towards each other with the shown speeds. They're 60 meter apart. And suddenly after some time they crash. So you have to find after what time they crash and at what distance they crash. Yes, so Shivank is correct as well. Mayank is correct. Kishore is correct. Samiksha as well. Yes, Siddharth, you are also right. Rest of you, what should be the answer? Okay, let's understand now the normal way of solving, or should I give some time? Okay, let's have 2 minutes more. Try. Okay, guys, so what's the answer? Rest of you? Okay, let me discuss. So first, see how we'll do it normally. So let's say the crash took place after X distance from the car. So if car has traveled X, how much the truck would have traveled? 60 minus X. The remaining distance should have been traveled by truck. Now let's apply speed equal distance by time for both of them, both of the vehicles. What will that be for the car? Car will say speed is 2 and distance is X by time t. For truck, speed is 4 and that's distance upon right 60 minus X by t. Now what to do next? You can just divide, isn't it? Divide the two equation. So on LHS, it will be 4 by 2. On RHS, it will be 60 minus X by X. So what is the value of X coming from here? 20 meters. And the moment you get the value of X as 20, time is 10. So this is how you normally solve it, isn't it? This is the normal way of solving. Everybody did like this? Yes or no? Everybody did the same way? Okay. Now let's learn a very new way of doing the same. This is the way in which we won't even have to move our pen to solve it. Why we don't even have to move our pen? Because think about the same in the relative frame. Now let's enter the world of relativity. According to this frame, just go and sit in the car. Just become the relative frame of reference. If you are in the car, you're observing from the car, what will you say? You will say, I'm not moving at all. Car is just standing at its own place. So who is moving? You will say truck only is moving. And with how much speed you will see truck coming towards you? Tell me. 6, right? You will say actually truck is coming towards you with 6. Why? Because in relative frame, your speed will also get added to the truck. So now overall speed will be 4 plus 2, isn't it? You will say truck is coming towards you with 6 meters per second. And if you are not even moving, who will be covering this entire distance of 60 meters? Truck will be covering it. So now it's so easy. There is a truck which is going with 6 meters per second and it has to cover 60 meters. How much time it will take? 10. That's it. You don't even have to move your pen. The moment you enter the world of relativity, you visualize. You don't have to solve anything. Just direct answer. And the moment you got the time, you can get the distance as well, X as well. So that's the beauty of relativity. Okay. All right. Now let's move further. This was an easy question of relative velocity. It was just to showcase how relative velocity helps in solving problems quickly. Now let's take something from accelerated motion, isn't it? So just like there is a relative velocity, there is relative acceleration also. What relative acceleration is all about? Similar. If let's say A is accelerating with A1 or AA, let's call it, and B is accelerating with AB, what will be the relative acceleration? I will call it relative acceleration of B with respect to A. And we'll put a vector sign here as well. The formula is same. Just split the variable and put a negative sign. AB minus AA. That's all. This is the relative acceleration. I hope everyone is clear. All right. So can you guys tell me, if you drop two objects, let's say there's a pen and there is some other object like this, both of them are dropped. So while they are falling, what is their relative acceleration with respect to each other? With what acceleration they will see each other moving with? Yes, Shivank, you're correct. Samiksha, correct. Kishore, correct. Kaivalya, correct. Ellen, but what is that, Ellen? They are freely falling. I guess you can guess what AA and AB would be. So I think each and every individual of class can answer this. Two objects are freely falling. What is their relative acceleration? So Shambhavi, does acceleration depend upon mass? No. It's the force that depends upon mass, right? F equals ma. Acceleration is independent of the mass. Whether you drop a huge rock or whether you drop a tiny marble, both will fall with the same acceleration. Yes, Jain, Jaini, you're right. Yafi, no, that's not correct. Ben Matthew is correct. Maitrey, not correct. No, Akhil. No, Ellen, I'm asking what is the value of relative acceleration? Give me acceleration of B with respect to A here. What will be that? No, Dhanush, again, try to understand. I'm not asking whether their accelerations are equal or not. I'm asking what is acceleration of B with respect to A. That's all. Yes, Maitrey, now you're correct. Akhil, not correct. Nrityashri, what is that? What is AB and AA? Do you know their values? Believe me, you know that. Yes, Mayank, right. Yafi, correct. On YouTube, Rohan S has answered correctly. Siddharth, again, you're doing the same mistake. You are telling me AB is equal to A. I'm not interested in equal or not. I'm interested in getting the value of ABA. That's all. Yes, Dhanush, you're correct. Akhil, you're correct. Karen, correct. So, Snehal, what is the value of AB and A? Substitute it and then find it. Yes, Siddharth, right. I don't know why you all are facing difficulty in this. It's so easy. If these objects are freely falling, Shambhavi, what is that? Again and again, I'm asking, what is AB and AA? What all of you are doing, you are just using the formula here and you are saying, okay, AB minus AA, sir, this is the answer. But what is AB and AA? Who will going to tell you that? That you have to visualize here. So you should quickly understand, if the objects are freely falling, any object that freely falls, what is its acceleration? Acceleration due to gravity. Both will be falling with acceleration due to gravity. So when you will substitute, it'll cancel out. And so the relative acceleration is 0. That's the answer. Answer is 0. Is it clear? Both are falling with the same acceleration, and hence the answer would be 0. All right, everybody clear? This is so interesting to visualize. Mathematics may seem very ordinary here, but the real life visualization is so amazing. Because think about it, what it is telling you. It is telling you that normally when objects are dropped, they speed up as they go down. This was very first time visualized by Galileo. Galileo saw that whenever things are dropped, they accelerate, their velocity increases. And we are saying that according to A, B speed will not increase. It will be constant. Isn't it? Because if according to A, B has no acceleration, that means B's speed won't change. It will remain what it was. So from the frame of reference of A, this is so amazing. A feather and a bowling ball fall at the same rate. Yes, Dhanush, given if there is no air. If there is air, then feather would going to fall very slowly. It will come down very slowly because air resistance will push it. Yeah. But if it is vacuum chamber, a feather and a metallic ball will fall at the same rate. At the same time, they will hit the ground. Okay. Yeah. Now, some people are always confused why all the objects fall at the same acceleration. Shouldn't it depend upon the mass? As somebody asked here as well. I think Shambhavi asked. So we should understand that the force that pulls the object is the gravitational force. If let's say this has mass m1, this has mass m2, then what force is acting on A? m1g. That's the force on the first. And what's the force on 2? Force on 2 is m2g. So I do agree that their weight is different. Weight does depend upon the mass. Heavier object will have more weight, lighter object will have lesser weight. But what if I ask you guys to find the acceleration? Acceleration is just force by mass. Just divide by the mass here. F1 by m1, that is g. And what is F2 by m2? That is also g. So accelerations are independent of mass. Is that clear? No, Cavalier, we are talking about here no air. We are talking about vacuum. Okay. Even though if let's say air is there, then acceleration would vary only by a little amount. It will not be same in that particular case, because air resistance does depend upon the shape of the object, how much shape it is having. That will cause air resistance force. There'll be another force called buoyant force, because air is a fluid. So it applies an upward force on any object that is in the air. But we are considering ideal scenarios. No air, everything happening in vacuum. So I hope this thing was clear to everyone. Relative acceleration of them was 0. All right. So let me ask another question then. So this question goes like, there's a building and the building's height is given to us. Well, that's too tall. This is the building. And here is the base of the building. We are dropping a stone from the top. It is being dropped. And in the same line, we are throwing a stone upwards. This is B. So A is dropped and B is thrown up. B is thrown up with 20 meters per second speed. And the height of the building, it's such a huge building. It's 40 meters tall. So high. So question asks, after, if let's say both of them are dropped at time 0, I mean not dropped, one is thrown up, one is dropped at the same time, t equals 0, then after what time they will going to crash? After what time they hit each other? Samiksha, A is dropped. If something is dropped, what is its speed? 0. Yes. So A was not given any speed. It was just dropped. Yes, Siddharth has got the correct answer. No, Jay and Jainil not correct. Yafi is correct. Ellen is correct. Dhanush, that's not correct. Maitreyi is correct. Rohan S on YouTube, you answered correctly. Shambhavi, no, we are asking time, Shambhavi, not speed. We have given meters per second, that's speed. Dhanush is correct. Karen is correct. Snehal correct. No, Shambhavi, it's not correct. Akhil is right. Samiksha is correct. Okay, so let me discuss, guys. Now, one way is again the conventional way, but that's so lengthy. Like the similar one we had in the truck and car. That first you assume one has moved x, other has moved 60 minus x. Similar thing you can do here. You can say that A traveled x, so B will travel 20 minus x. And you would have to consider equations of motion for each one of them because both of them are accelerating due to gravity. Their speeds will be changing. And then you write equations of motion and it becomes so lengthy to solve. Okay. If you want, I can show you that way first as well. So first is the method one, the conventional method. Method one. Method one is, suppose after being dropped, they hit after time t, somewhere here, let's say they hit, and A has traveled x. Then how much the B has traveled? 40 minus x. And now we would have to apply equations of motion. We would say that A has traveled x distance with the acceleration g and initial speed 0. That's what you will say. And so you will apply an equation of motion, which is s equal ut plus half at squared. What is the s value for A? X. Ut. What is u for it? U is 0. So first term gone, half at squared, which is gt squared. That will be the equation for A. Now let's write the equation for B. All right. Now all of you can see I have taken downward positive because I am taking gravity positive. So when I apply the equation for B, I must see what is going to happen there. The displacement of B is upward. So I must take it as negative, isn't it? I should write here s equal ut plus half at square again, but s will be negative 40 minus x. S equals ut. Now it even has initial velocity, but pointing upward. So that will be negative ut plus half gt squared. Now here you see, I've taken it as positive g only because g is downward, which is positive. Only upward things are negative, isn't it? Okay. So now what can I do? I have equation number 1 and equation number 2. Well, I can substitute instead of half gt square as x in the second equation, right? So try that. Negative 40 plus x equal negative 20t. Instead of half gt square, we'll have x. X cancel. And we get time as 2 seconds. That's the method 1 of solving this problem using equations of motion. Okay, done. Now let's see the method 2, which is the way we all should do, because that's the method of relative velocity. And you will realize it will be so easy doing that way. If I start observing things with respect to B now, let's say we are observing with respect to B. According to B, it is at rest. It is not moving. So who will be moving? According to B, A will be moving. Entire distance of 40 meters, the building's height, will be covered by whom? Will be covered by stone A. And if we ask B with what speed it is moving, so you can see B was moving with 20. Now it is at rest. So that 20 will be given to A, right? A will appear to be coming down with 20 to him. And will the speed of A be changing with respect to B? What do you think? Will the speed of A be changing? Well, somebody might say, yes, sir, why not? Because gravity is there. So the speed will increase. Don't you think so? What do you think? Will it change? Nobody is answering. Will the speed change? That doesn't matter, Samiksha. Both will give the same result. It will not. So it will not change. So then what will happen to gravity? So what about gravity then? Won't it cause any change? Yes, Dhanush is right. We should also see the relative acceleration. Will B be able to see any acceleration of A? No, because B's acceleration is also G downwards and A's acceleration is also G downwards. So what is the relative acceleration of A with respect to B? 0. We did that question, right? Just right now. That if two objects are having acceleration of G, then relative acceleration is 0. So amazingly, with respect to B, the speed of A will remain 20 only. It will not change. Because according to B, gravity doesn't exist. That's the most amazing thing. And that's why I'm telling you, we are entering the field of relativity. This is how crazy the idea is. And that's why you will be surprised to know, guys, Einstein actually rejected the idea of Newton. Newton said that the gravitational force acts. That is a reason for an apple to fall down. You know what Einstein has said? Einstein said gravitational force doesn't exist. Can you imagine somebody saying a statement like that? Gravitational force doesn't exist. According to Einstein, there is no gravitational force. That's the amazing world of relativity. So now question arises, then how we are all staying at the earth? If we jump, we again come back. Isn't that due to a force? So that Einstein has explained very beautifully in his theory. If we will get time, we will going to learn it later. Okay, that's how he gives all the equation of space-time bending. Okay, so here with respect to B, A has no force on it, the world of relativity. And so so A will just travel with 20 meter per second. And how much distance it will cover? 40 meter distance. So how much time it will take? Time is distance upon speed, or just 2. In a single step, we got the answer. Here we had to deal with many equations. Here just the visualization. Okay. So yeah, that's about relative speed. So today let's keep it limited to this. And in the next class, we will come up with a new concept. All right. So do research more about relativity today. See how Einstein completely destroyed Newton's idea, which was actually a good thing to do, because that's how you will able to eradicate many errors in Newton's theory. Okay. All right, guys. So that's it for the day. Goodbye, everyone.